Hi, I'm Tomek. I've been working in the Wrocław branch for quite some time now, and today I'd like to talk to you about GraphQL and Relay and why it might be a good idea to include them in your front-end and back-end stack when you have React application on hold. So, first of all, a slight introduction or reminder about React. Why do we love it? React introduced and popularized concept of reusable components. It's also guided by a great design, like it promotes explicitness and separation of concerns while writing your code. And from my experience, it's also very easy to add React to existing application that's running on a different stack. Whereas, for example, with Angular, it's not so easy because everything needs to be either Angular way or no way, or you have troubles. One thing that React doesn't give us is data management. Because let's remember that React is just a library for rendering components. It just handles the front end, just the rendering stuff. Doesn't really care about data in your application, about state of your application, and that's cool. But usually right in modern world, single-page applications grows to be more complex. So we usually attach something to also manage data of our applications. The examples are flux pattern introduced by Redux, which is just unidirectional flow of data in the application. It was promoted and extended by the framework, by the library on the right, which is Redux, which also added immutability. Both of them promote what React also promotes, which is a separation of concerns, which is a very good thing. But there's a case. Let's talk about microservices. And right now, when I say microservice, half of you will be like this, and the other half may be like this. So, it's also a very popular concept right now to not to have a monolith on the backend, but to split the application to several microservices, of which each of them manages their its own data and so on. But let's use a case when you have a mobile application, the mobile client trying to get the data for the application. The case here is that we have a simple betting service for offers, something like Allegro or eBay. And the architecture on the backend is split into service for users, service for products, service for bids and offers, and another service for shipping, because this is just an example. So let's imagine what data needs to be fetched in order to fully present everything that we want on a single product page to the end user. First of all, we need authorization, because if there is no authorization, we don't want to show anything. So first request goes to user service, the response comes back, and then we can probably either get some session management or some token that we can use in other services. So we send another request to a products service that tells us, okay, this product is in the database, we can render it. After we get a response for product, then we can query bids and offers just to show everything that's related to the product. And for example, if those were REST APIs, then each of the bids, each of the offers may lie under separate endpoint. So each endpoint would return only data for a single offer. So we have to make multiple requests here. And at the end of the page, we also want to display some shipping information. That's OK. But remember that our case is that we are using mobile client. And mobile network is much slower than what you have on Wi-Fi or LAN or something like this. For example, if this was the 2G network, the Edge or GPRS or something even worse, then this would be much more different than what you have on localhost. Just in other words, it will be horribly slow. One common case in applications that is also underlying ground for GraphQL and Relay is that first of all, we display spinner to the user. Then there's goes a request to authenticate and authorize the user. Then we grab all the necessary data from the backend while still rendering the spinner. And then we finally show everything to the user. So this is our architecture back again. Client, first of all, needs to know where all the services are, because there is no, basically client has to have, for example, hard-coded URL to user service, to product service, to bidding service, to bid service, and to shipping service. It also has to know how to authorize in each of them. Also has to handle the format of the data that is returned, and all the other caveats in the API. So let's say, for example, that products service was done by one team that really loves JSON and everything, and the other service is a legacy service that was done using, I know, Java Stack and XML. Client then needs to, well, parse this data, combine it, and you know how hard it might be. So pretty soon, you figure out you may need something in between. Some gateway between the client and the services, gateway that will be capable of translating data that is provided by the services into something that the front-end client can use. Another real-world use case that I've dealt with recently is that there was an old and boring products API in one of the projects, which was being replaced by the shiny new products API version 2, which won't have all the problems that the first version had. But the requirement was both of them had to run simultaneously. And there was a need to sometime get data from product from the old legacy one, and sometime get data from the new one. So this is also a use case for gateway, which would figure out whether we're dealing with a new product or with the old product. Will request the appropriate service and translate the data from the service into something usable by the client, so the client doesn't even know that there is some legacy system. After you realize that gateway between the backend and frontend is something that you may need, there comes a question, how to write it. There are multiple approaches to this, and today I want to talk about GraphQL, which as React was introduced by Facebook about 2 years ago. So what is GraphQL? GraphQL is not the data management system for React. It reuses the pattern of React for having one thing for handling one case only, and not having a tool that does everything and nothing at the same time. It's just a query language. GraphQL can be implemented in the gateway. So is GraphQL an API server? Nope. It's just a schema. This may be confusing at first, because when someone talks about GraphQL and Relay and so on, you may think about, okay, so GraphQL is some kind of server that I run and, well, it just integrates. No, GraphQL is just a schema. It's just the schema definition language in which you can describe your API. For example, you can have something like this. This is a very This is a very simple example, but whole language is also pretty simple. It doesn't have any rocket science inside. So we can see that we have basic types like string, enum, string, int, or float. We can also have a list. So in this case, offers will return a list of offer, which is also a nested entity. There is also a support for enums. So currency can be specified when requesting initial price of the product. We can say we want an euro or USD or something. And also, if you think about the exclamation mark is GraphQL's way of saying that this field is required in the response. It also includes some interface for pagination, which is composed of connection, things like connection, edge, node, and page info. It goes like this. When you request a collection of items that should be paginated, you actually get a product connection, which contains information about current page. So all the cursors, information whether there is anything left after this page, and edges. And for each edge, you get an actual object that you want and cursor for this object, because, whoops, sorry. Yep, here we go. Because Facebook, well, realized and told the world that cursors are the way to paginate for things on while doing requests. How does the query look like? Querying for data in GraphQL is pretty simple. You may, after seeing this, you may think that this is something like JSON, and in fact, if you compare what is queried for and what is returned, in response you get JSON. So you can, for example, match, well, you can see that this is something like JSON object without with just the keys without values. Values are in the response that server provides. One nice concept about GraphQL is that it returns only things that client requested for. So we can in the schema previously. You can see that we have sorry, which field? So for the offer, we also have user and product, but you can see that they are not included in the response precisely because we didn't request them. It also has a very nice side effect of API extensibility, because let's say that we, for some reason, also need to display username next to their offer. We just modify the query and let the GraphQL let the GraphQL resolve the underlying user for each offer and return it to us. The advantage is that we don't, the backend doesn't need to be modified if the schema is right. It also has support for mutations. I don't want to go deep into it, but this is the way to modify something in the backend in our system. And again, this is a simple mutation, and this is a response after sending this mutation to server. Again, the most important thing about GraphQL is that it doesn't specify really anything besides the schema and schema language. It's entirely up to you how you implement both querying, mutations, and resolving. I will go into it in a couple of slides. For mutation, the definition of mutation is just a query that changes something in the system. So it's not specified whether it creates a new product, or it updates it, or charges the customer, or whatever. It's just something that may change the state of the system. Important thing here is that in the mutation, you can also define a response that server will respond with. So we can see that after adding new product to our system, we can immediately get its value in the response for mutation. So, what are the good parts? I've realized that just after hearing this for 5 minutes, it might not be that obvious. But what are the good parts of GraphQL that really convince me that this may be the next big thing? First of all, it's declarative, not imperative. While interacting with the API in the old way, for example, sending a REST, serving a request to the REST API, you have to figure out, the client has to figure out if the client has to figure out what fields are in the response and then somehow parse them. You may know another language that is declarative and not imperative, which is SQL. SQL tells database what fields are required, what format data should be returned on, and possibly with some filters like age or population for country. But it doesn't really tell database about which sorting algorithm to use or whether to use indexes or not. It just defines, give me this data, I don't really care how you do it, just give me it. The same thing is with GraphQL. Client just sends a request to the server, to the gateway, telling, give me this data. I don't really care how you get them in whatever way you want. Just give them to me. Another thing is that it's very precise. I mean, it returns only what was explicitly requested. And this allows for extended client without changing the backend. So for example, as we saw on the example previously, if we wanted to add one field to the response, we don't have to touch backend at all, assuming that the schema and resolvers are written in a good way. We just need to add a new field to our query, and boom, it just appears. And the thing I told previously about, which is that GraphQL doesn't really specify what technology it has to be written in, or what are resolvers and how to resolve objects. It's also a good thing because it focuses only on one thing, which is defining the schema, and that's all. If you want to write a server in GraphQL, the GraphQL server, here are all the libraries you can use. And this is example implementation done in the GraphQL.js, which can also be plugged into the Express.js server on Node. So two things worth of noting here is that there is, I'll go to the schema and root in a couple of slides, but plugging it into the application, running it is pretty simple. The schema is the same thing that we saw on the slides above. Which defines what your API looks like, what to expect in the response. And the nicest thing, I think, about GraphQL are the resolvers. For each field that is included in the response, for each field that client requests, a resolver is run to figure out what to do with that particular field. So here you can see, do you have? Oh, okay, I have. Here you can see that we have. This is, let's say, a resolver for a product. This is a class product that can be returned to the front end. And here's the root query. So, for example, if we send query to the GraphQL for products, it will run this function, and then you can see that for each product, it will return a new instance of the product class. And you can see inside the resolver, we can basically do anything we want. So it can be some computation. It can be a request to ORM or database. It can also be a request to another service. So if we have a microservice architecture, it just can be a HTTP GET to another service for some field. And also we can see that in the product class, if you request the name, then this function will be invoked, and whatever it returns will be put as a name. So if we just want to get the name of the product, then we'll just get this row name. That's pretty simple. If we want initial price, then we can also include some very basic computation to return the most appropriate price depending on the currency. And for the offers, there will be a separate request sent to another service to get a list of offers attached to this product. So, since GraphQL is not a data management system of React, and topic of this, really I have only this time? No. I still have 30 minutes left. 15. Since the topic of this presentation, of this talk, is something that React application will like, let's go into something that can be plugged into React, which is called Relay, which is also done by Facebook. By the way, all of these technologies are done by Facebook. Remember that we're still in this context that we have a single gateway that hides the underlying implementations of all the services, hides them from the client. If you have any aversion to React, then sorry, but we're going into some examples which contain components. Let's say that we have this structure. Very simple, we just display a title of the name of the product, initial price, and list of offers together with usernames. So we can have following components. This is just product that has product header and offers list underneath. Pretty simple, not really much to do here. So the problem is how to ensure that all the data is displayed in right places, that all the components get the most appropriate data for them. We can use something like this, which is just sending requests to the API, resolving, waiting for a response, then composing the big data that will be plugged into the first component. But then we have, for example, the issue with requests to the offers, which lie in the different service. This is a very, very bad example. Don't use it anywhere because you probably will need some kind of a data management. For example, you don't want to hardcode URLs. You don't want to send them send the requests only when the page loads. You probably used or will use or know Flux-like solutions. This is based on Redux together with Redux Func middleware, which just defines the actions that can send requests and then put pull an action into the reducers. I don't have a code for reducers, but reducers will parse the provided list and update the state of the whole application. You can also use something like Redux Saga to make it more asynchronous, but that's not really the case here. This is how it looks for rendering the application in in Redux solution. It looks better because we delegate managing the state management to Redux. We just define the actions. We just define the reducers, and Redux takes care of making sure that actions get executed, the reducers run, and then rendering the component each time state changes. So it's better. But as you can guess, my case here will be that Relay is maybe more suited for this particular tasks. And that's because Relay relies on something called containers that wrap your components. This is something like a definition of what data component needs in order to be happy and be able to display whatever it wants to display. So we have a product header component which displays name. We can define for this particular component that it will need a fragment, which is another concept of GraphQL. It will need a fragment on product, and from product it will need name. The advantage of this is that we put data definition of what components needs very close to the component itself. In the previous example in Redux, we would have to maintain the state between. We'd have to make sure that all the necessary fields are in state, and then make sure that component really gets everything that it wanted. Another nice thing is that in React we pass props top down. So the root component gets all the props and distributes them to the children. So children should not be very aware about what goes on in a level above. The same concept is also here. You can see that in the root component we have product header and offers list, and also the initial price of the offer. And you can see that in the container, we define that we want initial price that will be used in this component, but also we have some dependency. We have children that want some data, but the only thing that Relay requires from us is to define which fragment to use. So for product header, we want a fragment called product. For offers list, we want a fragment called offers. And the nice thing about this is that product component really doesn't care about what data the children component really needs. It just says that, okay, I have these children, they need some data, go get it for them. Rendering is also pretty simple. I would say it's simpler than in the case of Redux, because Relay has a concept of something called network layer, which basically takes out the management of all the requests that go to the server. So you can just specify the address of your GraphQL server, specify your queries, which are called routes. This is not something like React route. It's an entirely different concept, and it's just bad naming. And just render it, and it also happens in the same way like with Redux, that Relay takes care of rendering what's necessary when needed. So going back to this architecture, advantage of that of having gateway and having GraphQL in the gateway is that we can send a query to the GraphQL, and assuming that our schema is right, the GraphQL will take care of sending requests using the resolvers. So for single query, which can be, well, we don't need to specify all the endpoints in the gateway. GraphQL does that somehow for us. It will send all the appropriate requests to the services using the resolvers I showed you previously. And the advantage of this is that, assuming that we are still in the context of mobile client running on a GPRS connection, is that there will be a single request to the gateway. All the responses will be grabbed from the services, which will happen much quicker than this request, and everything that client needs, and only the client needs, will be returned here. So what's Relay good for? It takes away, as I said, it's somehow a trade-off. If you compare Relay and Redux, it's a trade-off. You give up explicitness and you give up control on the network layer for ease of usage in your components. So assuming that you don't need to do anything fancy with your components, so the most appropriate use case for Relay is that we show a spinner and then wait until everything loads and then display all the components rendered. If you're willing to give up what the control that Redux gives you, then Relay may be a really good thing. Another good part is that it composes. Well, sorry, it will be shown in the later slide. So another good thing is that Relay manages giving only those props to components that I requested. So we can see that there is a previous query for initial price and some things from product, and the product header asks for name. But in scope of this component, there will be no product name. The product name will be undefined because Relay hides it from the component. The component can get only what it requested, and also promotes explicitness, well, not being able to pass some props because they are already here, or already in the parent component. They have to be explicitly defined in a container. So this is the product header component. You can see that although product initial price was requested in a parent component, it's not available here because this component only requested name. Relay is also capable of figuring out what data it really needs to get from the backend. So assuming that we have a user entity, we need those 4 fields. So in the first query, those 4 fields will be requested. But then we go to the next page, which doesn't have last name and join date, but instead has avatar URL and Facebook URL. So in this page, in the next query, Relay will take care of sending the query for you, but it will ask only for those 2 things. And if you go to the next page, where the only new thing is the date of birth, the next query will be just for this 1 field. So it also all looks nice, really nice, but as you probably assume, there's a catch somewhere. For me personally, Relay introduces a little bit too much of magic. As I said previously multiple times, it's less explicit than, for example, Redux. You just inject a network layer and things like just happen, data magically appears in the components. If it works, it's awesome and flawless. It's really very nice to be able to modify the query in the fragment in the container and see that data is automatically requested from the server and it just appears. If it doesn't, that's when you probably Google it, right? But when you compare React and Relay, both done by Facebook, both, well, maybe probably by the same engineers, you will see that, first of all, React is just one layer to learn. It's just components, just rendering that stuff. Relay operates on 3 layers, which is frontend, GraphQL schema, and backend, and gateway server, and you have to code them all by yourself. React is also more mature. It's 6 years old right now. It was released 4 years ago, and Relay is only 2 years old. And there's also a limited numbers of tutorials, examples, and those that are available are not that really good. And remember that this is still JS world. This is a version in the Relay repository. It was not 7 days ago. Right now it's probably 10 days ago. The Relay team introduced something called Modern Relay, which has entirely different API than Relay that we used up to this date. So it's like Relay version 2, which has entirely different API. And, well, yeah. To conclude, the development with GraphQL and Relay feels really great, especially when you have the microservice architecture. It does a lot of things for you. In my humble opinion, Relay is not as mature as, for example, React to recommend it to everyone. And please remember, it's also not a silver bullet for all the cases, but it's worth trying out. And last but not least, you might not need them at all for your simple to-do app clone. You might be as well good with simple single request to the backend and, well, parsing response without using Relay, Redux, and anything else. So that's it. Thank you for listening. And do we have some time for questions?
I will allow you to have one short question before we go to the next presenter.
Anyone?
If not, thank you. Thank you very much.